Example 1, Part A. Factor the greatest common factor of 4x plus 12. So what we will be doing in this problem is we will be factoring. That is somewhat the opposite of multiplication. So in the previous section, we were using the distributive property to multiply. In this section, we're going to go backwards. We're not going to multiply numbers in. We're going to take numbers out in order for us to have a multiplication problem at the end. So how would we start? In this problem, what we will do is we'll first factor the numbers, and then we will factor out the greatest common factor. So let's start with 4x. Now 4x, if we factor it out, we could factor it out as 4 times 1 times x. Keep in mind, factoring is just taking something and writing it as a product. Let's go with the number 12. How can we factor 12? As 4 times 3. So now if we look at all these factors, we see one in common, and that will be the number 4. This is what we will be factoring out. So if we factor out the 4, how will our problem look like? We would have 4 outside, and in parentheses, we'll be left with the rest. 1 times x, which will give you x, and we will just be left with plus 3. So when we factor the greatest common factor out of 4x plus 12, our problem will be 4 times x plus 3. Example 1, Part B. Factor the greatest common factor of 21x plus 7y plus 14. So I will begin by factoring the numbers. So 21x, we could write it as 7 times 3 times x plus 7 times y. We could just leave it as is, 7 times y. And 14, we could write it as 7 times 2. And now if we analyze all three terms, we see one factor in common, and that factor will be a 7. That's what we will be factoring out. So if we factor the 7 out, we will be left with 7, open parentheses, 3x plus y plus 2. The good news about factoring is that we can always check our work. If we are not sure that this is the correct answer, we could always distribute back the 7 into the parentheses and verify that we do get the original problem. Example 1, Part C. Factor the greatest common factor of 2x squared plus 3y minus 7. So I will go ahead and factor each term out, and once I factor each term out, I will try to determine a greatest common factor. So 2x squared, we could write it as 2 times 1 times x. 3y, we could write it as 3 times y, and negative 7, we could write it as negative 7 times 1. As we can see, there is no common factor within all the terms. So what that means is that our problem will remain exactly the same. So 2x squared plus 3y minus 7. We will consider this a prime trinomial. Example 1, Part D. Factor the greatest common factor of x to the power of 3 plus 3x squared plus x. I will go ahead and factor each term out, and then once I factor each term, I will try to find that greatest common factor. So x to the power of 3, we could factor it as x times x times x. 3x to the power of 2, we could factor it as 3 times x, and x, we could factor it as x times 1. So now that we have our each term factored out, we will look for our common factor, and in this case, all three terms have an x in common. So if we factor that x out, we will be left with x. Then in parentheses, for the first term, x times x, which is x squared. For the second term, 3 times x, which is just 3x. And for the third term, we would just be left with 1. So our final result will be x times x squared plus 3x plus 1.